Welcome, everyone. Welcome to Nüwa. This is year 2100, and you are arriving to the Martian city of Nüwa. You are new citizens, and I'm going to be your first guide on this tour. I work at the Mars Technical University, which you can see here on the valley. So why Nüwa? Where the name is coming from? So Nüwa is the ancient goddess of protector of humans on Earth. It created the atmosphere and also melted 5 stones that are the 5 cities of Nüwa. So these 5 cities, there are 2 of them in the Tempe Terra region, Nüwa and Fuxi. This is where we are now. 1 in the polar region that has access to water, and 2 more in Marineris and Ascreos to get access to minerals. Also 5 cities is a matter of resilience in case there is a problem with one of the cities. So the design principles of Nüwa were very clear and very strongly implemented through the whole design. First, it has to be self-sustainable growth, meaning that all resources need to be sourced locally. We cannot depend on outside growth, on outside imports. Resilience is also very important. This is implemented through redundancy and modularity, for example. And the third one, and very important one too, it has to be an exciting place to live, because this is the way we expect to attract these million people, the people that you today are coming to join us in this city. So, our development model is based on a very basic concept called the city unit. A city unit is essentially everything that takes from the environment, air, water, minerals, to put a human into the city. It also includes the machines that are needed to collect, transform, manufacture everything that you need for this human. This is housing, this is the part of greenhouse, this is domes, services, and so on and so on. So, you, as a citizen, you will be asked to contribute about 0.12 city units every year. If you reach this threshold, we can enable exponential growth. This is the development model for Nüwa. In the first phase of Nüwa, many years ago, the first 10 years, it was still relying on imports, and it was operated a bit like a corporation on Earth. The people were workers for the corporation. Now, in the second phase, more people started to come, exponential growth started really to kick in, and we started to make new institutions like the Mars City Council and the university, and also the start of the economy. And today, you are here, you are in the third phase, where Mars is becoming a city-state, essentially, with a constitution, a parliament, and a senate that still has the representation of Earth. Also, the economy is shifted to improve life quality instead of just pure development. So, as you know, coming to Mars is a life choice. So what you do, basically, you have to pay a fee in Earth currency. You have to commit a percentage of your work time to the city. And what you get in exchange is the trip to Mars. You get habitation for free. You get life support and food and access to all city services of a modern welfare state. You also get something called One Mars City Share. So why is it used for? This is to start the economy. So we have a currency called the micro. Every time the city produces a surplus in city units, micros are distributed among Mars city holders, Mars city holder shares, which can be individuals like you, for example, but can also be companies, can be organizations. With these micros, one can go to the council and buy, for example, real estate. You can get a higher or larger habitation or buy space to start your own businesses. You can also trade the micros for services like road trips with a rover, or you can also go to one of our wonderful sushi restaurants to get awesome food. So if you like it, it gets even better. Now, Director Muñoz will show you the buildings of the city.
Dear all, welcome to the vertical city core of Nüwa. I am the architect that has been supervising the construction of this city in Mars for over the years. The city is based on a highly scalable solution that is located in cliffs. But why cliffs? Well, they offer a great amount of advantages versus other locations in Mars. Let's look at some samples. If we actually want to build on the surface of Mars, we have some challenges like the exposure to radiation, potential impact from meteorites, or even the pressure from inside of the buildings. That means that we need a lot of material on the skin and on the structure of the buildings to solve those problems. And that is not very sustainable or economical. We can obviously solve all of those problems by going underground, but then we add other problems, which are the lack of natural light, which is so essential for the well-being of humans. Or even, what do we do with the excavation we get out of it? The advantage of a cliff and the proposal that we did on the city is that it combines the best of both worlds. But most importantly, the cliff offers a huge advantage at other locations in Mars, like craters or lava tubes, and that is that the geological composition of cliffs is highly compact, which in a city is extremely useful because it offers a highly compressed solution. In a low amount of colony, like 1,000 people, let's say, is not really that important. But when we are on a large scale of people, like 200,000 or even 1 million, being able to have a 3-dimensional compressed solution is very, very important. So now that we know that we are on a cliff, we know that we are divided in 3 areas: the wall, the mesa, and the valley. Let's look into the wall. The way that we take over the wall is we create tunnels with an average of 10-meter diameter. Those tunnels go very deep inside the cliff, as far as 250 meters. And they provide a 3-dimensional net of spaces where we spend most of our days in Mars. At the same time, those tunnels go close to the side of the wall. And not only they bring the light, but also we have what we are calling green domes that act as the buffer spaces where we have vegetation and where we provide opportunity for the community to socialize. Those spaces can be seen in the outside of the cliff by what you see on the screen. You see the diversity and the different types that we have, which is essential for creating identity. Inside the green zones, we have some samples here. Some of them are small, while others are bigger. And we have a lot of nature for the community to enjoy and even do camping. But let's look at the program. How are we actually solving all the different activities inside the wall of the cliff? We are doing it through what we are calling a macro building, which accommodates to 4,440 people. The strategy is not very different from a block of a city on Earth. It basically comprises of buildings. In this particular case, the key is that they are all modular buildings, 6 residential and 6 buildings for workplace. And that allows for a highly scalable model, which at the same time is very flexible. Not only that, but it secures that every macro building is different from each other, creating an identity. Additionally, what we have is that every macro building is self-sustained. So the community does not really need to leave the macro building on a day-to-day basis if not needed. Those programs are the residences and the workplace, but also they do have facilities and small urban orchards inside the macro building, along with recreational spaces associated with the transportation. If we actually look into the elevation of the cliff, we see the scalability of the macro building. We see here the modules that we mentioned, and we can identify how we grow horizontally and vertically as needed. All of them are connected with a vertical transportation system. Here is a view of how the spaces will look from the inside of those facilities. And the residential quarters are deep inside the cliff in order to protect us from the challenges that we have. You will soon enjoy them. But self-expression is very important in Nüwa. So we have here some opportunities for art domes. The valley is also fundamental. And basically what we have here are spaces for the entire city to socialize and interact. In this particular case, the main strategy is having domes which are transparent, which that allows to have a relationship with the outer world. Being transparent offers some challenges in regards to the potential risk to radiation. But the way we are solving it is by having really large canopies that overfly those big buildings. And we dump all the excavation that we get from the wall on top of those canopies, so that material is what provides the protection. Highly sustainable and recyclable. So Some of those buildings can be seen here that can be used as a public parks for the community, for the city, or even hospitals or museums. Below those areas, we have larger tunnels of 20 to 30 meter diameter, what we call galleries, and they accommodate intra-city transportation and sports arenas and other large space requirements, including what we are calling tunnel gardens, which are spaces for the public to interact when at the same time are connected to the high-speed elevating system, which is what connects all the macro buildings and the mesa and the valley. In the middle of that transportation system, we have sky lobbies. And the transportation system is very similar to the way they work on Earth on super skyscrapers. The mesa includes like the spaces related to the food and energy production as well as manufacturing. The solution is very scalable. And if we look at the areas, basically we have the entire city solved in 278 square meters per person, which is a little bit less than 3,000 square feet per person. And thanks to that scalable solution, we are applying the same design principles that we did on Nüwa on other cities, like Avalos on the north, or we have the marineri cities. Now, let's go back to our capital, where my colleague Gisela is going to explain to you how we keep you alive.
Hello, and welcome from the mesa. There are no humans living up here, but we have a lot of important systems that make sure that the city stays alive. One of those systems is a life support system. It makes sure that the 1 million people living on Mars get all the resources they require every day. 1 million humans will consume every day 820 tons of oxygen, 1,500 of food, and about 10,000 of water. The system also takes care of the waste produced and makes sure that we can process it to get frictional resources for the citizens of the city. To do that, the life support system is composed by several living organisms. Crop and microalgae are the main food source, but we also have animals, insects, cellular meat, and other living organisms to ensure a balanced diet. The crop and the microalgae, besides producing food, also take care of the atmosphere regeneration. That means that they consume the CO2 that we humans produce, and thanks to photosynthesis, they produce oxygen, by at the same time contributing to the water recycling. Bacteria in the system take care of the waste, both liquid and solid. You can imagine it is very important from the human urine, for example, to recover the nutrients and the water. Animals and insects both live in the same compartments as humans do, since they have similar atmospheric requirements. But the crop and the microalgae live here up in the mesa in a CO2-rich atmosphere in the so-called agricultural modules. The atmosphere of these modules and the human compartments are completely separated, and they only exchange gas through a control system. CO2 and water can be extracted from the atmosphere thanks to cold precipitation. Plants, as they do on Earth, also require light here, but since we are farther away from the sun, we need artificial lighting as well. To be power efficient, we're using blue and red LEDs mainly. All the systems I've introduced you form the life support system. This is a closed system. That means that once the system is running, we don't need to put any extra inputs inside the system. We are able to recycle all the waste that we produce into fresh substances. But for every inhabitant that we add to the system, we need to increase the size of our life support system. And we do that by increasing the size of the crop area in 90 square meters and adding different substances, nutrients, water, oxygen, and nitrogen. And what's very important also in the system is that we will need power, not only to start it, but to keep it working. And for that, we need 37 kilowatts per person. That is a lot of power. And we also have to consider that we will also need power for other things, like the habitats, manufacturing, and so on. That's why, next to the agricultural modules, we also have the power modules, a large area of power modules. We have photovoltaic systems and solar concentrators to provide us with energy from the sun. But we have to consider that photovoltaic systems are very difficult to build here on Mars because we need the resources to build them. So our main source of energy are solar concentrators. But you've probably heard about dust storms here on Mars, right? Well, that's why we have a nuclear power plant as well. Don't worry, for safety reasons, it's far away from the city. But it makes sure that we can get power even in stormy days, so our systems, the most critical ones, can keep on working even on those days. And those are the most important things we have here up in the Mesa. And now it's time to continue your tour in the community gardens, where Miquel will tell you about how life will be here in Nüwa.
Thank you very much, Gisela, and welcome everybody. Martian society must be fully supported by the concept of community. Mars is a very hostile planet where you need to rely on the other people around you. Here, the relationship between the individual and the community can be summarized as, if you want to come to Mars, join us. Therefore, education and society should encourage Nüwa citizens to actively contribute to a healthy community. Also, the fact that we all are shareholders of the city, which in turn provides for all the basic needs, helps closing the circle. Additionally, living on Mars forced a radical change in the way we understand the relationship between us and the natural environment. Here, we do not adapt the environment to our comfort, but are forced to adapt ourselves to the planet, taking care of what Mars offers to ensure the sustainability of the trio: individual, community, and environment. As you can see, Nüwa is a great opportunity to create something new. But this opportunity also involves the Earth, since the way Martian society has evolved to a model based on community and sustainability may be a driver to face the biggest challenges on the blue planet. Nüwa's educational model is totally aligned with this concept of society, and all age groups, including adults, should have the opportunity to learn and to continue learning. We are receiving a lot of immigrants just like you, typically in your 30s, and yeah, many of you will start families here. So you need to know that universal access to childcare is guaranteed. Also, educational programs are committed to developing children physically, socially, emotionally, cognitively, and strong emphasis is given in teaching how to learn new skills from available resources like books or digital media. This is very important for both the city and the students, because here the tasks and work distribution change rapidly over time. And then at the Mars Technical Universities, students will become scientists, engineers, software developers. We do need professionals able to produce robots and to program artificial intelligence. And then these robots and the AI are the ones that do the hard work. Mars Technical Universities also offer support to entrepreneurs, program for visiting scientists from Earth, and many other options. Regarding the services, Nüwa provides all citizens with the basics, so be just sure that you have everything. The access to medical care is a fundamental right on Mars, and the health facilities are maintained by the city. Recreation facilities engage citizens in physical and social activities, campings, arts, and so on. Intra-city transport is based on elevators and light trains, whereas transport between cities uses based on paved roads. Also, out-of-dome operations can also be done using pressurized rovers. Finally, and very important, all citizens must always wear a personal monitoring device. This has the function of, first of all, activating safety protocols in case of emergency and also monitoring the health of the citizens. And now let's talk for a minute about the rocket that brought you here. A robust and scalable Earth-Mars transportation system is vital for the success and sustainability of Nüwa and all the other cities on the red planet. This system must, first of all, ensure the flow of immigrants to sustain the city's growth and also be the pillar of an economy based on Mars-Earth relations and for the future exploration and exploitation of resources through all the solar system. The system is based on a shuttle, which transports people and cargo in reusable spacecrafts using a direct ascent mission architecture. The interplanetary trip takes an average time of 250 days, and the spacecraft can travel back to Earth using fuel obtained from the Mars atmosphere. To complement the shuttle service, an Earth-Mars station started operating some years ago to be used as a large-capacity transport system. This station consists of an asteroid placed in a cyclar orbit that periodically moves between the Earth and Mars. And this is very, very convenient since almost no fuel is needed to keep such a station on its orbit, and spacecraft are only used to move the passenger from the surface of the planets to the station and back. And now I pass the word to Guillem, who will finish the presentation from the spaceport.
Oh, hello. Welcome back. So let's wrap up before you go to your new homes. Let's summarize a bit what it takes to include one of you in our city. So essentially, the way we proceed to make these estimations is first make a list of physical assets, things that you have already seen, like construction, life support, energy infrastructure, but other things as well, like tanks, like computing facilities, like mining operations, which are typically done at tens of kilometers of the city, computing, social services, hospitals, everything has been accounted for. And once we have this list, we can proceed to the next step, which is taking what we call the material equivalence table. We list all the materials that we typically use on Earth, the ones that we typically use on Mars, or we can use on Mars, and try to find matches. So for example, carbon on Mars, very important. Carbon is extracted from the CO2 of the atmosphere itself. Another important thing, for example, it's just an example. Iron. Iron is the workhorse material. We don't want to use exotic alloys of other metals. They are very difficult to extract, and also using iron allows full recyclability and reusability of most of the things that we have. So collection, then we have to add the cost of collection, transformation, and manufacture to all these estimates and all these matches, and add all the energy that is needed to make all these operations. And at the end of the day, you end up with what you call, the city unit budget. Wow. Well, this is a bit busy slide. You don't need to panic, because there are only 3 take-home messages that you should know and you should be aware. So, including one human on Mars, on Nüwa, requires 1,300 tons of minerals mined. This seems a lot, actually is a lot, but actually is very comparable to what is used in a developed country on Earth. Construction, greenhouses, energy facilities, manufacturing is what it takes most of these materials. And actually the welfare state takes a very, very small part of this, which is good news, because this is why we have so good facilities. Another thing that we need a lot is water and CO2. It's not drinking water. Actually, this water and CO2 are needed to start organic chemistry. Organic materials are crucial for modern civilization. We need organic materials to support construction, but also to make medicines, to make fuels, and to make other things like insulators and all sorts of devices. And finally, is continuous power. It has been already mentioned, we need a lot of continuous power, of which only 40 kilowatts are for the life support system. The other 80 kilowatts are essentially just to support development. This also means that every average human should be contributing about 10 times more than what an Earth citizen would do. So if you compare to Earth, 10 kilowatts is what an Earth citizen typically uses. So how to bridge this gap? So it has been bridged or has been solved using standardization, using robotization, and using artificial intelligence, all at design level. So artificial intelligence takes all the control on the logistics, and the humans have much less work to do. So with all this said, you are almost ready to go home, but finally, let's wrap up and see where it all began.
Back in 2020, more than 20 space enthusiasts from different countries joined forces to conceive this city. They summarized their concept in a 20-page document that they submitted to the Mars Society competition. Nüwa stood on the shoulders of giants. It built on decades of predecessor concepts, and it summarized countless hours of work. Their design combined new and old concepts. They proposed technical, urban, socioeconomic solutions that have become a reality here today. Some people often said, 1 million people on Mars, that can be possible. Well, they were wrong. It was possible. It was just not easy. The cliff-excavated city concept solved many intrinsic issues of the Martian environment, but it required a highly multidisciplinary approach. Sustainability and resilience were a must. We're also creating a strong sense of identity, because it is not enough to build the infrastructure. It has to become a place to be proud of. The Nüwa concept was a realistic opportunity to establish the first large-scale off-world settlement, so it engaged private and public institutions from everywhere. Back then, Earth was entering a climate emergency, and living on Mars has helped us to solve some of these problems back on Earth. There have been many challenges, yes, but ultimately, it has worked out. Here you are today. Welcome to Nüwa, the first city-state beyond Earth on Mars.
Hi, I do architecture and urban planning.
I do conveying.
I do future scenarios.
I do architecture and graphic design.
Life support systems.
Chemical engineering.
Space psychology.
I do architecture.
Mining and rock mechanics.
Fashion and art.
I'm an astrophysicist. Architecture.
Astrodynamics.
In-situ resource utilization and manufacture.
Architecture.
Brain-computer interfaces.
Space engineering.
Architecture.
Planetary geology and geochemistry.
I do economics with fish.
I do planets.
I do rocket science, and we are SONet.